So the goal of a decision tree is to achieve perfect classification with a minimum number of decisions. The algorithm is based on an inductive strategy with a greedy algorithm. It works very well for a small number of attributes, but can't be used if you have hundreds of variables. And any Boolean can be represented, for example, kids, yes, no, but you can also take things like age and put it into sort of bins or thresholds and have age lower than 50, yes or no. The key tuning parameter is when to stop splitting, and there are three basic strategies for that. The first one is all observations in any one class are equal, which is very unlikely to achieve with a big data set, just because you have outliers and other things. The second thing is you have a maximum number of leaves, and the third thing is that you have a minimum number of observations per class. The central problem about decision trees is how to choose the best attribute for the algorithm. And to do that, we're using a concept called entropy with the variable age, which measures the average or expected amount of information, and it's measured in bits and depending on the probability of the variable. To make this a bit more clear to you, I will quickly run you through an example for credit risk default. First thing you do is you calculate the bits of entropy for the target variable. So how much information does the variable default contain? In this case, it's a bit of a complicated formula that I won't explain, but it's 0.8813 bits for a credit default variable. The second thing is you calculate the conditional entropy, which for example is h of default given you've missed a payment. Here 0.8763. Then you calculate the reduction of entropy to find the information gain. Basically that's 1 minus 2, which here is h of default minus h of default given a missed payment, and that is 0.005. That is quite a low number, and you're very unlikely to use that in your decision tree. Finally, you choose a variable with the highest information gain. And this you have to repeat at every step of a decision tree. Thank you very much for your attention.